I've mentioned before about the standard equation that we did in the previous two exercises, but I've mentioned that we're only dealing with functions. And that's why we need to split this equation up into a lower half and an upper half. So first of all, to do that, and I have an exercise where I explain this fully, you first have to isolate the y minus k square, because in this case we still have an implicit equation for the y. I want an explicit equation for the y. And in order to do that, I must isolate the y minus k square and then draw square roots both sides, and then I get a negative square root and a plus square root. There, we don't write it, but there's a plus there. If I do not have a shifted one, then our domain is minus r to r, but because I'm now dealing with the upper part, I'm dealing with the plus one there, so our answers can only be positive from 0 to r. So it's from there to there. And if I shift it, depending on where this hk is, it can be anywhere on the xy axis. If it's there, then from there onwards I will move my r to the right and r to the left, and then I'll get the boundaries minus rh and plus rh. And my range will then be from this value here, which is my k value, plus r. So from the smallest one is k and the largest one is r plus k, because the range, that broken line there from the center to the circle, the circumference of the circle, is then the value r plus k. The same with the other sketch here. I've just shown you that it's not necessarily moving to the right. It can right and up, it can move left and down, it can be anywhere. So we start with the center and from there we determine that, but that rule will hold. If we now look at the lower semicircle, then with the center 0, then it's the lower half of the circle, everything below the x-axis in this case. We still have the same domain from minus r to r, but now we have negative y values from minus r to 0. The center is 0, 0, and the radius is r. So let us look at the shifted one. First of all, I have minus the square root. That's my standard form here. My domain, doesn't matter where this hk is, whether it's here or wherever it is. Once I've determined the hk, then I add r to get the right hand side of the domain, and I subtract r to get the left hand side, the left value of the domain. It's always in close brackets. If I look at my center here, from the x-axis to the center is the value k. In this case it will be negative, but it doesn't matter, it will sort out itself there. So to get then to that point on the circle, I must subtract r because I'm going down. So it starts at minus r plus k and it ends at k. And my center is hk and my radius is r. It's actually easier to start with the center and the radius and then work according to that. For the green graph, f of x equal to the square root of 4 minus x squared, we see this is the standard one with center 0. It's the upper half of a circle. So there we will have a plus. There's nothing, there's a plus there, so it's the upper half. And what I want to focus on is this domain with the closed interval from minus 2 to plus 2. We can also write it as the set of all x's such that x is in between 2 and greater or equal to minus 2. So that's another way to denote the domain. And the same with the range, we say that is all the y's such that the y's is less than or equal to 2 and greater or equal to 0. That's another way to express it. Keep that different notation for your reference. So first of all, I want to look at the blue graph. When we look at the blue graph here, we see that this is this g of x. Then we see that we have two endpoints. The one is a minus 3, 0, and another one is b, 3, 0. That's the two endpoints. So the blue graph will be g of x. It should have a negative square root. And if we look at the radius, then we see that we have 3 minus 3, which is equal to 6 divided by 2. So the radius is equal to 3. And we have a midpoint of the origin, 0, 0. Our domain, we can read it off. It's from minus 3 to 3. And our equation will be 3 squared, which is 9, minus x squared, because it did not shift. It's a standard one. My h is equal to 0, my k is equal to 0. There was no shift involved. And the range, if I look back at the graph, the lowest value here is minus 3 and the highest value is 0. So to finalize the blue graph, we said the domain is from minus 3 to plus 3, but there's an open dot here at B, so that means that we cannot have a closed bracket there, so the right bracket should be open, a round bracket. It doesn't influence the range though, because although the 0 is not included at B, it is included in A, so we can write square brackets for the range of the blue graph. And that's the only thing that we need to notice. So after we've done what we normally do, we go back and check the endpoints of each graph. Let us prove algebraically that the domain of y equal to plus the square root of r squared minus x minus y squared plus k is exactly that. To calculate the square root, the inside of the square root, remember that although it's not written there, there's always a little 2 there. We don't write it like we don't write the plus, but it's assumed that we're doing a square root. So the inside of the square root, the r squared minus x minus h squared should be greater or equal to 0 before I can get the square root. So to solve for x, I must first factorize this. So I can multiply it out, but it makes it more difficult. This is like something like r squared minus k squared greater or equal to 0, where we have r minus k, r plus k greater or equal to 0. So let us factorize. So if I factorize, I get r minus x minus h times r minus x plus x minus h greater or equal to 0. So I want the x value. So in this case, I will have r minus x plus h, and I will have r plus x minus h greater or equal to 0. This will give me minus x plus r plus h and x plus r minus h greater or equal to 0. So I want the plus there, so I'm going to do this, x minus r minus h. So I'm dividing by minus 1, and x plus r minus h. Then the sign will change because I'm dividing by a negative value. I can do this, or I can in order to use a concave up, I will use that. Otherwise, you can use a concave down parabola to solve that. In this case, I will have x minus r plus h and x plus r minus h less than or equal to 0. So that means I've got a parabola. And which one is the smaller? The smaller one is this r minus h, and the bigger one is r plus h. I want to solve for x, so I will then write x minus r plus h less than or equal to 0. So if I now look at the values minus r plus h and r plus h, then I will have a parabola with the minus r plus h on this side and the r plus h on that side. So that means my x, to be negative, x should be in between r plus h and minus r plus h from that graph there. If I can also not change the sign and use that and just use the concave up graph. So that means that our domain will most definitely be from minus r plus h to r plus h. That is our domain.